Welcome back, students. So in the previous class we discussed about logarithmic differentiation. We have done few problems, and I said few problems you have to work on your own. Maybe it's for the first time, correct, right? So what I will do is I will explain the remaining problems also. So let's see later on. Anyway, in the home exercise you have many number of problems to work. So I will complete the remaining problems of the logarithmic differentiation today. Once again, I hope that all of you are practicing every day. It's a new concept, so please practice and learn it on the same day. First thing. Second thing, hope you are practicing the formulas every day. Keep doing it till you are sure that yes, I have learned. Don't leave it. Okay, so keep practice. Okay, and as I said, the best way of learning is write it few times and try to get it. Okay, so let's continue from where we stopped. So in the last class we stopped at problem number 13. So that was x power y is equal to y to the power x. Now let's go to problem number 14. It is given by cos x whole power y is equal to cos y whole to the power x. So as I said, first time you are learning this concept, so I will explain all the problems from NCERT as much as possible. So once again you can notice there is no need to call the names. Function to the power function, both sides, correct, right? Now apply log on both sides. So the left hand side will be log of cos x whole power y. The right hand side log of cos y whole power x. Now apply the formula. Log of x to the power y can be written as y into log of cos x. The right side x into log of cos y. Log is applied. Now we will differentiate both sides with respect to x. The left hand side product of 2, right hand side product of 2. So both sides apply product rule. So left side when you apply product rule, first function is y, second function is log of cos x. So differentiation of log of cos x, 1 by cos x, that is for log, then for cos minus sin x, plus retain this log of cos x, and differentiation of y will be dy by dx. And now look at the right side. Right side is also product of 2. Again apply product rule. X multiplied by 1 by cos y, that is differentiation of log, then for cos y minus sin y, but it is a term of y, so after differentiating it is multiplied by dy by dx, plus log of cos y as it is, and differentiation of x will be 1. Both sides we have applied product rule. Now the next is, finally you have to find dy by dx. Look at that. In the left hand side there is the term of dy by dx, and in the right side also there is a term of dy by dx. So we will collect them to one side, take dy by dx common, simplify it further. So the left hand side, when I simplify, see we have sin x by cos x, that is tan x, there is a minus sign, so minus y tan x plus log of cos x multiplied by dy by dx. Now the right side, we can notice here we have minus x tan y multiplied by dy by dx plus log of cos y. Now the next is to collect the terms of dy by dx to one side. So as you notice, these are the two terms which contains dy by dx. So from these two, if I take dy by dx common, here we have log of cos x. Remember, this is shifted and then common will be taken. So when I am shifting, this minus will become plus x multiplied by tan y. And what is the term already present in the right side? Log of cos y. Now you are shifting this, so this will be plus y into tan x. Now in the next step we will just shift this one to right side. So this will be dy by dx equal to log of cos y plus y into tan x whole divided by, now this the whole term will be shifted, so this will be log of cos x plus x into tan y. So that's how it should be done. We'll move to the next one. So let's go to the next problem number 15. There's a problem in marker, so a bit lighter this looks, so I have changed it. So let's get into the next one. The next one is problem number 15. Problem number 15 is given by xy is equal to e to the power x minus y. Now actually without applying the log also it's fine, because this is not function to the power function, but it can be done with the help of the log also. Okay, so I will do with the help of the log. So let me consider log of xy is equal to log of e power x minus y. We have a formula, log of e power x is equal to x. Let's use this formula for the right side. So the right side is log of e power x minus y will just become x minus y. Now let's differentiate. The left hand side is log of xy. First for log, then for xy. Differentiation of log 1 by x, so it is 1 by xy, and that is multiplied by xy by using product rule. So x into differentiation of y plus y into differentiation of x. It's over. Now first function into it's over. Now the right side differentiation of x will be 1 minus differentiation of y will be dy by dx. So let's multiply this. When I multiply, x get eliminates, 1 by y dy by dx plus y get eliminates 1 by x. The right side 1 minus dy by dx. So let's collect the terms of dy by dx to one side and take common. So after taking dy by dx common, 1 by y, so on shifting this minus will become plus. So the right hand side we already have 1. Now this 1 by x is going to be shifted, so it's going to be minus 1 by x. Now let's take LCM on both sides to simplify it further. So the left hand side on taking LCM, dy by dx multiplied by 1 plus y by y, and the right side x minus 1 by x. So the simplest form what you can get is dy by dx equal to y will be shifted here, so x minus 1 multiplied by y, 1 plus y will be shifted here, so 1 plus y multiplied by x. That's the simplest form where you can leave this problem. Let's move on to the next one, problem number 16. If you can see the statement for problem number 16, find the derivative of the function given by f of x equal to 1 plus x multiplied by 1 plus x square multiplied by 1 plus x power 4 multiplied by 1 plus x to the power 8. And what they are telling is, after finding the derivative, you have to find something called as f dash of 1. Quite simple. After finding the f dash of x, their value of x will be replaced by 1. Now to do this, direct way, if you want me to ask product of 4 is there, will take lot of time if you go for the regular method. Now instead of that, it's better if I apply log, simplify, and then go for differentiation. So let's apply log on both sides. Log of f of x equal to log of the whole right hand side, what I have here, the whole thing, right? Okay, now then it will become log of a, b, c, d. We have a property, log of xy can be written as log x plus log y. By using that property, this will be written as log of the first term plus log of the second term plus log of the third term plus log of the fourth term. Okay, now product is being reduced to sum, and if it's in terms of sum, it's quite easy for us to solve it. So the left hand side will become 1 by f of x into f dash of x. We don't have y, it is f of x is being given, right? So log of f of x will be 1 by f of x, and differentiation of f of x will be f dash of x. Now differentiation of log of 1 plus x, 1 by 1 plus x. Differentiation of log will be 1 by x, correct, right? And now look at this, 1 plus x. Differentiation of 1 will be 0, differentiation of x will be 1. So no need to write 1, it's understood. Now let's go to the next one. Again like log x, 1 by 1 plus x square. Differentiation of 1 will be 0, x square will be 2x, plus the next one 1 by 1 plus x to the power 4. Differentiation of x power 4 will be 4x cube. And the last term 1 by 1 plus x to the power 8, that is differentiation of log. Now differentiation of 1 plus x power 8 is going to be 8x to the power 7. So what we need to do, quite simple. I need to shift f of x to right side. So I'll just write one more step before that. F dash of x will be equal to f of x multiplied by 1 by 1 plus x plus 2x by 1 plus x square plus 4x cube by 1 plus x power 4 plus 8 x to the power 7 by 1 plus x to the power 8. And now f of x has to be replaced by this. So finally, see, if f dash of x is over. Once you replace f of x, done. After that they said something called as find of f dash of 1. So what is f dash of 1? Quite simple. In the last step, what we have written here. In this step, let me find out this one separately. Okay, we have to find something called as f dash of 1. F dash of 1 will be equal to f of x multiplied by 1 by 1 plus x plus 2x by 1 plus x square plus 4x cube by 1 plus x power 4 plus 8x power 7 by 1 plus x power 8. The meaning of f dash of 1 will be f of 1, wherever x is there, just keep replacing it by 1. Okay, so that's the meaning of f dash of 1. Here I don't have a space, so I will find out f of 1 separately. In the given function, replace x by 1. Your first term was 1 plus x, so 1 plus 1, 1 plus 1 square, 1 plus 1 power 4, 1 plus 1 power 8. So simplify. 2 multiplied by 2 multiplied by 2 multiplied by 2 will be equal to 16. So this f of 1 value will be equal to 16. And in the remaining, wherever you got it 1, now replace that by 1. Wherever x is there, x value has to be replaced by 1. So f dash of 1 will be equal to f of 1 will be 16, 1 by 2. When I replace x by 1, 1 plus 1, 1 plus 1 will be 2. And here if you notice, 2 by 2 plus 4 by 2 plus 8 by 2. Wherever x is there, x value has to be replaced by 2. X value has to be replaced by 1. Now let's simplify this further. 16 multiplied by, if you are taking LCM, 1 plus 2 plus 4 plus 8. So you can eliminate this. 8 multiplied by, so 10 plus 5, 10 plus 5 will be 15. So just multiply this, that's all. So 15 into 8, whatever we get, that will be the required answer. So it's 15 into 8 is going to be 120. So first thing, find f dash of x, then find out f dash of 1. Yes, now students, we came to the last problem of this topic, logarithmic differentiation. Yes, I have left few problems in the previous main actually. Please solve those problems. So as I said, these topics I will do it. So let's consider problem number 17. Problem number 17, name is not given, so I am going to give a name. So y is equal to x square minus 5x plus 8 multiplied by x cube plus 7x plus 9. But they said something. You have to just differentiate this in 3 different methods. First thing, by using product rule. Second one, expand, and that means multiply, get a polynomial, then differentiate. And the fourth one, by logarithmic differentiation. So let's do one by one. So first method, they said product rule. So let's apply product rule. So left hand side dy by dx, right side x square minus 5x plus 8. First function multiplied by differentiation of second function 3x square plus 7 plus second function x cube plus 7x plus 9 multiplied by differentiation of first function. So that's going to be 2x minus 5. What we need to do, you multiply everything, just reduce this in the form of a polynomial. Don't stop it here. Multiply and reduce this as a polynomial, because at the end of this they have given a statement. Now will the answer be same in all the 3 methods? Now to do that, you have to just multiply, simplify and get it in the form of a polynomial. So more space consuming, so I will not be writing that. So let's go for the second method. Second method, they said first multiply, get a polynomial and then differentiate. So y will be equal to, I will multiply this now, x square will be multiplied for all. So x square into x cube, x power 5 plus 7x cube plus 9x square. Now multiply each term by minus 5x. So minus 5x cube minus 35x square minus 9 into 5. So that's going to be minus 45x plus. Now multiply 8 for all the three. 8x cube plus 8 into 7, that's 56x plus 8 into 9, that's going to be 72. Before we continue, better to simplify and then continue. So let's consider x power 5, there is only one term, and the next is, you can notice there are two terms of x cube. So 7 minus 5, that's going to be 2x square. Sorry, 2x cube. 9x square, once again, we have 7 minus 5 plus 8. So 7 minus 5 will be 2, 2 plus 8, so that's going to be 10. We have a term of x cube here also, right? Okay. Now the next, let's go for x square terms. 9 minus 35. 9 minus 35, it's going to be minus 26 x square. Only two terms of x square, right? Okay. Now the next, minus 45 plus 56. So how much that's going to be? So that's going to be 11x. The last is going to be constant, that is 72. The simplest form of y. Now differentiate this. This is going to be 5x power 4 plus 30x square minus 26 into 2. That's going to be 52x plus 11. Remember in the previous step, previous method I said you multiply, get it in the form of a polynomial. This is what you will be getting the same. I hope it's clear. Now the last thing, you just need to apply logarithm and then differentiate it. Now to apply log, once the log is applied, so this is going to be log y. The right hand side, when the log is applied, so there will be log of two terms actually. So log of first term plus log of second term. So the right hand side can be written as log y is equal to log of the first, that is x square minus 5x plus 8 plus log of the second term. What is the second term? X cube plus 7x plus 9. Now differentiate. So this is going to be differentiation of log y, 1 by y dy by dx. Again differentiation of log 1 by x square minus 5x plus 8 multiplied by, see log is over, right? Now differentiate this. So this will be 2x minus 5. Now plus the next one, 1 by x cube plus 7x plus 9. That is differentiation of log. Now differentiation of this will be 3x square plus 7. Students, what I will suggest is first shift y to right side, then simplify and then reduce it to the simplest form. Make sure the answer in all the three method will be same. So students, we come to the end of the logarithmic differentiation. Remember all these things, don't get panic actually. All these topics are very new to you, correct, right? So don't get panic, just sit, just practice once, practice twice, but definitely 1 or 2 times. Once you practice, you can learn this. Not at all difficult. Try to understand. I told you in the beginning itself, we will not going to invent any new methods, any new formulas from no one. Whatever formulas we have studied, whatever rules we have studied, now the same thing in a different manner. That's all. Okay, students, now let's try to learn the new concept. Now we are moving into the next type of differentiation. See, after logarithmic differentiation, you have something called as differentiation of infinite series. This is the next concept actually. I just want to tell you, this topic is that means in the board examination you will not going to face any problems based on this topic, but it is needed when we want to learn the topic of, when we go to the MCQs, particularly you need it there. So 1 or 2 problems I will explain this so that you can understand the concept. Okay, we're not going to learn anything much in depth. So just one or two problems to understand the concept of infinite series. So the first problem they said is y is equal to x bar till where? Infinity. X is infinitely increasing till where? Infinite number of terms of such kind. Students, just remember one thing. Out of infinity, for example, 1, 2, 3 till infinity. If I remove the first number, still I am going to call it as infinity only. I will not say infinity minus 1. No. The sequence is still going to be infinity only. In the same way, when a term is repeatedly written for infinite number of times, so out of that, if I retain this first x, what I have here, if I just close this, the remaining value still will be called as y only, because that is the term which is repeatedly written as infinite number of terms. Okay, this is what the concept is. A very simple concept actually. So this can be written as y. So retain the first, retain this. The remaining thing still can be called as y. So you have one more example that I will discuss later. Now it's been reduced to y is equal to x to the power y, function to the power function. So take the help of the previous topic. So it's not at all a new topic actually, but in board examination or in NCERT book you will not find any problem based on infinite series. But learn it, it will be useful. So let's consider log y is equal to log of x power y. So log of x power y will be y into log x. Now differentiate on both sides, 1 by y dy by dx, and on the right side y multiplied by x. Product rule for this. First function into differentiation of second function plus second function into differentiation of first function, and that's going to be dy by dx. Now there are two terms of dy by dx. Collect them and take dy by dx common. So if dy by dx is common, here it's going to be 1 by y. Shift and then taking common. So on shifting, so this will be it. Minus log x, and on the right side you have y by x. The rest is simplification. Shift this to the denominator of the right hand side. Simplify one or two steps after that thing. So this is how infinite series problem should be done. Now let's go to the next one. Problem number 2. So problem number 2 is given as y is equal to root of sin x plus root of sin x plus root of sin x till where? So this is repeated infinite number of terms. First try to understand what is repeated actually. Root of sin x is repeated every time. So out of that, if I retain the first root of sin x, the remaining still can be called as y. That's all the procedure. So this can be written as y is equal to root of sin x. I said I am going to retain this root of sin x plus as it is, and the remaining still can be called as y. So what we can do, you can differentiate directly, not at all an issue, but I will suggest you square and then go for differentiating. So on squaring, the left hand side will be y square, the right hand side, this is first on squaring, the right hand side will be sin x plus y. This is easy to go for it. Now the next, go for differentiation, 2y dy by dx, it's a term of y, so differentiation of y square will be 2y multiplied by dy by dx equal to sin x, differentiation of sin x will be cos x plus differentiation of y will be dy by dx. So differentiation is over, the rest is to find dy by dx. Shift this to left hand side, so this can be written as dy by dx. On taking common, here it is going to be dy. On shifting this and taking common, I am doing two steps at one time. And on the right side we have a term called as cos x. Now the final step, replace or shift this 2y minus 1 to right hand side, it goes to the denominator. So cos x by 2y minus 1. So you just need to observe, student, what is repeating actually, that's all. So let's move on to the next problem number 3. In this, y is equal to a power x and the next a power x till where? infinity. So which is repeating here? A power x is repeating. So once I will retain the first a power x, the remaining things still can be called as y. The concept is simple. Out of infinity, if one number is removed, the numbers are still going to be infinity only. By using this concept, so out of a power x which is repeated infinite number of times, retain the first one. The remaining things still can be called as y only. So this will be written as y is equal to a power x whole to the power y, or simply a power xy. Now you can go for differentiation directly, or you can take the help of logarithm on both sides. So the left hand side log y, right hand side log of a to the power xy can be written as xy multiplied by log a. On applying the log, the things will become simple, that's all. So the left hand side differentiation 1 by y dy by dx equal to, now here log a is a constant, write down first, apply product rule here, x into dy by dx plus y into differentiation of x will be 1. So we have a dy by dx term here, so we will multiply the right side, collect the terms of dy by dx and then simplify it further. Students, all these are word problems in the EPL. You can go through. There are actually 6 work examples. Please follow and just go through the steps properly. You can understand, it's not at all difficult. Afterwards, you have some illustration problem. There are 4. Please work out. And if you are unable to just get the solution for any of these 4, please call back to us. Okay. So it's a new one, and as I said, not there in the board examination concept. Please learn it. It's quite useful. Okay. So that's the way to solve the problems based on infinite.